Hello, Algebra students, and welcome to part 2 of lesson 6.2. We are still working with substitution method for solving system of equations. Please be careful and make sure that you are isolating a variable in the beginning. If you solve for 2y equals something, that y is still not isolated. You need to get y completely by itself. Y also has to be a positive variable, for example. But again, you don't need to solve for the y. You could be solving for something else to isolate for in the beginning. Topic 6 is all about systems of equations. So let's go ahead and hop right into the lesson. Two equations at once, and so we're finding the x and y value. Remember, if we can find an x, y value that works in both equations, that means that's a point of intersection. If we cannot find a point that works in both, that means they are parallel. And if we find that the lines are actually the same exact line, that's infinitely many solutions. We started out with graphing, but what we noticed is when we had to find that point of intersection, it was kind of tricky if it did not land on a perfect whole number or integer. So then we came over to substitution, but we're having trouble with substitution, mostly in that very first step of solving for one of the variables. But today we're going to look at these systems of equations in word problems and what does it look like in real life, and maybe it will help you put context on some of these equations. Example 1, Gemma sells tickets at a local fair. On Saturday she sells 800 tickets and collects a total of $7,680. How can Gemma determine the number of each type of ticket that was sold on Saturday? All right, so there's some important information in the picture here for us. So first of all, we're going to make two equations. The one equation is going to represent the number of each ticket. So in other words, adult tickets plus children's tickets equals a total of 800 tickets. So I'm going to use A for adult, C for children. A plus C is going to equal 800. My second equation is going to represent the cost from the tickets. So I have $13.50 per adult ticket, so 13.5 times A, plus 7.5 times C equals a total of $7,680. And so I already have those equations written for you up here. All right, so again, the number of tickets versus the value of the tickets. Okay, now what I'm going to do is I am going to solve for A in the top equation because I can do that just by getting rid of C. So I'm going to write this down here. So what I want to do, so A plus C equals 800, and I'm going to solve for A here. So I want to subtract C from both sides. I want to make sure that you do this step on your paper or your whiteboard because this is where most of you are making your mistakes. A is going to be equal to 800 minus C. Now, if I used the top equation to isolate my A term, I must use the bottom equation or the second equation to plug it back into. So I'm going to use 13.5 times A plus 7.50C equals $7,680. Now here's where I'm going to plug in 800 minus C. Now I need to distribute first. So I'm going to multiply. Again, use your calculator. Don't need to labor yourself with all this. So 13.5 times 800 is $10,800 minus 13 point, and I'm going to use 13.5C. Don't need to write the 0 every time. Okay, now we have to combine like terms. When I do that, I get negative 6C, but I still have that 10,800 here and 7,680 on the right. Okay, I need to get my C term by itself, so let me get rid of the 10,800. I'm going to subtract it from both sides. Now, of course, normally when you subtract, you have the larger absolute value on top. So I am going to, when I plug this into my calculator, I'm going to do 10,800 minus 7,680. Oops. It would help if I type it in correctly. I get 3,120, and that is a negative because my 10,800 was a negative. Now I need to divide by -6 on both sides, and as you can see, I am running out of room. There we go. And when I do this, I should get a positive number because I'm finding the amount of children's tickets. So a negative divided by negative is a positive number, so that's a good sign. 3,120 divided by 6 equals 520 children's tickets sold. Okay, now, when you plug it back in, it does not matter where you plug it back in. I'm going to choose this top one, A plus C equals 800, because that looks like it's going to be easier to use. So A plus 520 children's tickets equals 800. I need to subtract 520 from both sides. When I do that, I get A is equal to 280 adult tickets. So if I add up 280 adult tickets plus 520 children's tickets, I should get back to 800 tickets. But here, 280 adult tickets sold, 520 children's tickets sold. Was that a lot of work? Yes, but not too bad overall. Example 2. Seiko takes a pottery class at 2 different studios. Is there a number of hours for which Seiko's cost is the same at both studios? Okay, so what we're going to do is we're going to write an equation for the cost at one studio and another equation that represents the cost at the other studio. I'm going to use C for cost and H for hours. And so at the Community Pottery Studio and Club, it looks like it's $14 per hour. All clay is included. Please come and see us at the community hall. Okay, so cost is equal to 14H. That's it, $14 per hour. In the other studio, Private Studio Ceramics, it says $28 per hour plus $15 for clay. Bring this coupon for half off the price advertised above. Okay, so let's take a look. $28 per hour plus 15 for clay. Okay, up here I've defined the variables. I'm using C for cost, H for hours. That's just for me, and it's good for you to write that down too so you remember what each variable is representing. At the first studio, the cost was equal to $14 per hour. At the next studio, the cost was equal to $28 per hour plus $15 for the clay, but it also said bring in this coupon for half off. So it's going to be half of that amount. All right, so here's the thing. Both equations are already solved for C. So that step is done. They did something for us. And they're asking us after how many hours will the cost be the same? So I need to set this cost equal to this cost, right? I'm taking this 14H and plugging it in for that C. All right, so let's go ahead and give this a try. So I'm going to get 14H, the cost at the one studio, is equal to 1/2 28H plus 15, which represents the cost at the other studio. All right, looks like first I have to distribute here. Half of 28 is 14, and half of 15 is 750. Right? This is the same thing as 0.5 times each of those. And if you're taking 0.5, it's the same as dividing them in half by 2, dividing by 2. All right. Now I need to get all of my h's to one side. So let me subtract 14h from this side, 14h from that side. What do you notice? I'm left with 0 equals 750. You're not wrong. That's what happened mathematically. Is this a true or false statement? Does 0 equal to $7.50? Well, remember how We can also have, we can have one point of intersection, which means one solution, or we can have parallel lines, or we can have one overlapping line. This here is false. There's no solution, which means that if we graph this, these would be parallel lines, but there's at no time would the cost at each studio be the same. The cost will never be the same. The cost will never be the same at the two studios. False statement means no solution. So the cost will never be the same. Let's take a look at one last example. Negative 2y minus x equals negative 84.91. 3x plus 6y equals 254.73. Equations are right here. If you didn't print out the notes, you can write them down. Okay. Again, when I need to isolate the variable in the very first step, I am looking for a variable that does not have a coefficient on it. Now, I see that the x has a -1, but that's better than having a 2, a 3, a 6, because then I won't have to deal with any fractions. So this is what I want to isolate for right here. I'm going to isolate for that x. So I'm going to first copy down this equation because I notice this is where most of you are making your very first mistakes, is when you're first trying to isolate for that variable in the very beginning. Okay, I am going to add x to both sides because I want x to be positive. So I get negative 2y equals negative 84.91 plus x. Now, I have x positive. Why don't I get rid of the 84.91? It's negative, so I'm going to add it to both sides. Add 84.91 to both sides. Okay, even though I'm adding it on this side, remember I can't combine it with the y term because those are not like terms. So I have negative 2y plus 84.91 is equal to x. Now, if I use this top equation to isolate for my variable, I cannot plug this back into that top equation. I need to plug it into the second one. So I'm going to do that. I'm going to rewrite the second equation here, but this time I'm leaving a space for my x because this is what I'm going to plug in for x. Plus 6y is equal to 254.73. Okay, this was negative 2y plus 84.91. Okay, again, use your calculator. No need to spend all this time when this already takes this long to try to do it by hand. We're going to distribute. 3 times negative 2y is negative 6y. 3 times a positive is going to be a positive 84.91 times 3 equals 254.73 plus 6y equals 254.73. Okay, next order of business is I need to combine my like terms. I have negative 6y plus 6y. My y terms cancel out. I can't do anything with them. So now I'm left with 254.73 equals 254.73. Now what? Is this true? Does 254 and 73 hundredths equal 254 and 73 hundredths? Yes, this is true. Therefore, there are infinitely many solutions. If you had graphed these lines, which would be kind of tricky because We have decimal numbers, so it'd be hard to graph it exactly, but these are actually the same line. They would be overlapping. There's infinitely many solutions. Okay, that is it for the notes. I know this is still tricky. This time there's another component added in here that you have to write the equations to represent the word problem. So if you need any help with that, please let me know. That way we can be sure that you're starting off on the right foot.